Let's represent in a graph the function 1/3 raised to x. We can see that we have an exponential function, because the unknown value x is the exponent of a power. Let's draw both axes, the y and the x. And now let's make a table with different values. And let me tell you first that as it is a positive power raised to a number, it will always be a positive function. It cannot be never ever a negative function. So let's go with the values here, the x and the y. Let's give values to the x. For example, these 5 values here, and let's obtain the value of the y for these values of the x. That is just substituting these numbers. Let's go with a -2, and this function would be 1/3 raised to -2. A power with a negative exponent is just, as it is a function, we have to turn around it, just the denominator to the numerator and vice versa, and it changes the sign of the power of the exponent, so it would be 3 divided by 1 squared, that is 9. Let's go with the -1. 1/3 raised to -1 is 3 divided by 1 raised to 1, and this is equal 3. Now let's go with the 0. The image of 0 is 1/3 raised to 0, and as we know, a number raised to 0 is equal 1. This number raised to 1, that's the image of 1, is the same number, 1/3, and the image of 2 is 1/3 squared, it's equal to 1 squared divided by 3 squared, and that is 1/9. Let's write here the numbers, not the fraction, for 1/3 and 1/9. That is 0.3 and 0.1. And now let's draw these 5 points on the graph. For the -2 we have +9 for the y, for the -1 a 3, for 0 it's 1, for 1 it's 0.3, and for 2 is 0.1. As you can see, this graph will get very very close to the 0, but it will never ever get to touch it. So let's join the points here. And now, as I told you, this function, you can substitute any number you want, that it will never ever be equal 0. So you can see this graph is a decreasing function, and it is, as I told you at the beginning of the video, a positive function, and it will never touch the 0 even if the x is very close to the infinite, it won't be 0.